Οι ομιλίες και οι παρουσιάσεις θα γίνουν στα αγγλικά, καθότι έχουμε και online και είναι αρκετοί από το εξωτερικό που παρακολουθούν και εδώ στο ακροατήριο και η μελέτη ήταν όλη ετοιμασμένη στα αγγλικά. So, ladies and gentlemen, members of our institute, dear associates, I wish to welcome you to today's workshop, which is dedicated to carbon capture and storage. This is not the first time that our institute has taken the initiative to examine, investigate this relatively novel technology. May I remind you to some of you who are here that back in 2009, our institute organized a special seminar with the support of the region of West Macedonia in Kozani, with the support of the IEA and Alstom at the time, to look into the possibility of using CCUS technology to extend the life of lignite-fired plants, which, as you know, are the dominant fuel source for power generation, or used to be. It was very successful, that seminar. And we had many inquiries. But after a week, I went with the then chairman of our institute, John Hadjivasiliadis, to meet the newly appointed chair of Public Power Corporation, whom we knew, and to inform him what we're doing as an institute. And at the time, he asked, did you actually organize such a conference event in Kozani? I said, yes, and most of your people, the managers of the power stations were there, and they were very excited with this possibility. He said, that's monstrous, that's terrible, you shouldn't do such things. We said, why? Because of the very high cost involved. We don't want to discuss these technologies. Blanket, that's it, finished. Unfortunately, this is the situation which prevails today at PPC for different reasons. And that's why in this study, although we took attack from PPC and from lignite fire stations, this particular study is not concerned with CCUS applications in the power generation sector. We bumped across the issue 3 years ago, when the Ministry of Energy asked IENE to investigate the transition of lignite areas, such as West Macedonia and Megalopolis, into the new era of decarbonization, and how the new type of technologies could take the lead and provide employment, and all that. So we reminded ourselves of CCUS. We discussed this with the ministry and PPC and said, no, terra incognita, don't touch the subject again. Okay. But we're a restless type of organization, as you know, and we were not happy. So 2 years ago, we contacted various companies, organizations in Greece and abroad, and we looked into the possibility, not, of course, for power generation, but for the industry. And we were very happy with the response. It took some time. We floated this proposal about 2021. Eventually, we started working on this in summer of 2022, and eventually, 10 months later, we had the study which you have in your hands today. So first of all, I wish to thank the 5 companies involved in this venture, which was a step-by-step information and knowledge addition to this, because we had groups, we had meetings as we were going along, and this proved really valuable for the companies and ourselves to understand where the trend should be, what the line of attack should be when we're talking about CCUS in industry in Greece. Of course, CCUS is not a new thing. It has been applied in the oil and gas industries for many years. We have the example of some very, very well-known examples, such as the Sniper field in Norway. We have the Texas Basin, where again we have several applications of enhanced oil recovery. So it has been used systematically by the oil and gas industry. And I think the oil and gas industry has a vital role to play in energy transition, especially when it comes to CCUS, but also in the wider sense because of the tremendous organizational skills and expertise that the oil industry has in managing energy projects. So I think CCUS is a point of, is a meeting point where the oil and gas industry has a rendezvous with the energy transition. And maybe some of the expertise will be used for CCUS, but it is an opportunity for the oil and gas industry to expand into the wider energy transition issues. As I said, this study was prepared on a multi-client basis with the participation of companies sharing common interests and aspirations in their operations towards a cleaner environment. Ultimately, it is hoped that this follow-up report will open the way for the companies individually or by group activity to pursue their investment plans within the net zero framework and the various CCU venture opportunities. Before giving the floor to my trusted colleague, Nikos Koukouzas, who took the main, he had the main responsibility of this from a research point and view, and worked closely together, of course, with the other with our other colleagues who will share the floor later today. I wish to thank Dionysia Virinopoulou, who is not here today. She's a member of Parliament, New Democracy, and she is the head of the Environment Committee of Parliament. So when we informed Dionysia a few years ago, 3 years ago, what we were doing, she was surprisingly very supporting. And when I said, why? Because she says, I've studied this in the USA, I know it's something that is coming up, we should be in this and this and that. I said, okay. So we had one supporter right from the start at political level, which helped us very much to pursue this idea. So I say no more. I wish everybody a very good day on this conference workshop. And Nikos Koukouzas, you have the floor. Thank you. Thank you.
Good morning, everybody. Kalimera σε όλους. I think I have to speak in English. So thank you very much for coming. We have, I'm going to give a presentation on the main outcomes of the study. The study named Prospects of the Implementation of CCUS Technology in Greece and Southeastern Europe. The contents of the study are, we have actually 6 chapters. The first chapter relates to CCUS and its importance. Second chapter is related to CCUS in Greece. Third chapter, CO2 storage options in Greece. Fourth chapter, the hydrogen, combined use of hydrogen and CCUS technology in Greece. Number 5 chapter is the CCU implementation in Greece. And finally, number 6 is the legal and regulatory issues. So first chapter, I think everybody knows about CCUS. CCUS is the name of the carbon capture, utilization, and storage. So refers to a suite of technologies. So the main goal of these technologies is to mitigate the greenhouse gases. So we can use these technologies to capture CO2 from different point sources like power generation or industrial facilities. And then we transport CO2, we compress and transport by pipeline and ship or rail or truck. And finally, we inject CO2 underground into geological formation, so for CO2 storage. It's a new technology. Of course, it's not a new technology. We have facilities operating since 70s, mainly in the United States. And we used this technology in the past for the processing of gas, natural gas in Texas. And then they store CO2 underground. In Europe, we have, as Mr. Saboli said before, we have the Sleipner project operating from 1996, if I remember well, of around 1 million tons of CO2 inject per year. So we have at least 20 million tons CO2 already underground in saline aquifers at a depth of 1 kilometer. So what is the capacity for these facilities in the world? The capacity is to capture more than 40 million tons of CO2 per year. So we have already 30 new integrated CCUS facilities, and most of them are in the United States, of course, and some of them, as we said, in Norway and North Sea. And we expect to increase this number of CCUS over the coming years. So what the main reason is that we need to decrease CO2 emissions up to 2040 of about 6 gigatons CO2 per year. So first is the capture of CO2. We have 3 technologies, the post-combustion, pre-combustion, and oxy-fuel combustion. So the main things is that post-combustion is captured from the flue gas produced from combustion of fuels with air. Pre-combustion is that this CO2 is reacted with oxygen to produce synthetic gas. Of course, we have carbon monoxide and hydrogen as well. And oxy-fuel is used the oxygen for combustion rather than air, producing flue gas with water and CO2. Second stage is the transporting of CO2. So once we capture CO2, we compress it into liquid state at the pressure of about 10 times the atmospheric pressure, and then transported through pipelines or ships to store. So we have a large scale of CCUS facilities in the world using pipelines. In the United States, for instance, we have compression and transportation of CO2 for commercial use through 50 individual pipelines with a length of around 4,500 miles. In the United States, there are some pipelines used for transporting CO2, including EOR. EOR is the enhanced oil recovery, so that means that we get also oil from the rest of the extraction by injecting CO2. So we have an extra benefit of this technology for the oil company, or geological storage. So In Greece, in our country, we have several constraints and difference compared to the previous countries, especially related to the industrial landscape, but also related to pipelines or even the infrastructure or the geological storage sites. So we found that there are the CO2 pipelines depending on the country industrial emissions, proximity to the sites, potential storage sites, and the government policies. CO2 storage, three main technologies for long-term storage. So we have the geological storage, ocean storage, and mineral carbonation. Of course, we have to take into consideration that there are some risks related to the site assessment. So we need to get into consideration all these facts before drilling. But we have in mind that in other countries this is already done. As I said before, EOR, the enhanced oil recovery, is probably the best technology. This is the ocean storage, but this is probably something that's going to be quite for the future. Mainly, we have the EOR and mineral carbonation. In mineral carbonation, this is the technology. So that means that CO2 involved with metal oxides form carbonates, and this is in situ, in the place where we inject CO2. So we have one big project named CarbFix and CarbFix2 in Iceland, in Europe, where we have the first large-scale mineral carbonation operation. So what is the situation in Greece? As you can see, we have the greenhouse gas emissions in Greece for the period 2005 up to 2020. So we have a decrease. If you can see, the first row is the CO2 from 113,000 in 2005 up now. We almost, we put it, we have half of it, 55,000 tons of CO2. That's probably because we decreased the number of coal power plants over the last years. But still, we have some CO2 to store. By sector, this is the greenhouse gas emissions in Greece by sector. So we see that energy sector is the most pollutant, let's say. Of the 74,000 in 2020, 51,000 comes from energy, and the rest for other uses, industrial uses, agriculture, waste. We have in Greece around a potential of 30 million tons to capture CO2, and we would like to go to 4,000 megatons potential by 2040. As it concerns the power generation, we have the coal combustion. So we have, as we said before, we decreased the number of coal-fired power plants, but we still have some. So we have these power plants that Kardia does not exist anymore, Meliti and Agios Dimitrios still exist, but we have the policy from the government to close everything up to 2028. So that means that we can have only Ptolemais 5. But Ptolemais 5, even though it's a new coal-fired power plant with higher efficiency compared to the previous power plants, has around 4.5 million tons of CO2 per year emitting CO2. So we have the scenarios for CO2 capture in Greece. We did some work in the past using post-combustion techniques. This was modeling, let's say, using a 650 megawatt coal-fired power plant and trying to make some estimations to transport CO2 to put it in the saline aquifers in the northern Greece. using, as I said, post-combustion technique, chemical absorption with amines. So we have some already work done in the past for that. But now we need to take into consideration all these new facts related to the decrease of CO2 from the coal-fired power plants. CCUS in general is increasing in the world. So we have 50 large CCUS projects. We have 2,700 new facilities to be installed by 2050. And we have also new projects. Some of them are indicated here in this table. There are, you can see also the leading country. Some of them are quite research projects like strategy CCUS or risks, but some others, for instance, LEILAC, you see Belgium or Germany, this is CO2 capture in cement factories in Belgium. So it's a pilot project. And some of them, like Athos, it's Athos, Aramis, they're quite big commercial project nowadays. So they include the full chain of CCUS. And even though I say Netherlands as a leading country, there are a couple of countries involved. I was involved also in the evaluation of this kind of projects from the European Commission, and I have to say that they are big, we call them interconnected energy facilities in the European Union. So so the member states like Netherlands, UK, Norway, they are all agree, and the oil companies like Shell, Total and others, they also agree to make all these commercial projects to realize all these project activities with huge pipelines. For instance, in Athos, they need to construct an undersea pipeline of 200 kilometers. So they're big projects, not only research. So these countries are very much advanced compared to Greece. Of course, there's other scenarios from using the CO2 from Komotini power plant to put it in Prinos Basin through the flue gas in Greece, separated, compressed, transport. I'm not going to give you all these numbers now. It's in general, we have a network in Greece, and we have ports, quite important ports like Thessaloniki, which is around 140 kilometers from Western Macedonia. We have the industrial zone, the CO2 emitters from PPC and others. We have Kavala, Alexandroupolis, Igoumenitsa. So we have a closeness of the industrial facilities with CO2 emitters and ports and emitters in Greece. So there are different also scenarios related to the existing network to CO2 transport using the Trans-Adriatic pipeline. And potential storage sites like Pedalofos and Deptachori in the Meso-Hellenic Trough, the West Thessaloniki Saline Aquifer, and the Prinos Basin Oil Reservoir. So you can see in the table that there's also some estimation. These are already found in the study using source Ptolemais, Meliti, or Agios Dimitrios, or Komotini power plants going to Pedalofos or West Thessaloniki or Saline aquifers. So also we had an estimation that this is a quite long time estimation using different storage capacities, pipeline investment cost, transport cost. In going to storage sites in Greece, which is normally the third chapter in our work. So do we have in Greece the storage capacity to do all these CCUS activities? This is the question. I think that we have it. We use these different criteria, technical and economic criteria, geology. If there are any wells drilled, there are seismic information. There is a vicinity with industrial activities, proximity to the transportation facilities. So using all these criteria plus more geological criteria like porosity, permeability, integrity, the depth of the formation, we believe that we can go to at least three places: Mesohellenic Trough, West Thessaloniki, and Prinos. And this is the map of Greece with the estimated CO2 storage sites. You can see Prinos with 35 million tons at least. This is with the data that we have available. We have Mesohellenic Trough with quite large of number, but we need to say that we have more uncertainty with the geological data related to Prinos. And we have West Thessaloniki. So I can go one by one the storage sites. So this is Mesohellenic Trough. We have the Heptachori Pedalopho. The storage thickness is around 600 meters. There is a cap rock. We need to have always a cap rock that gives us the certainty that we have CO2 stored there. So it's around 1,500 meters thick. We have a storage capacity of around 216 million tons of CO2. The space, the depth, porosity, 15%, pore volume, the hydrocarbon presence, there is probably at the depth. Injectivity, if there is any leakage risk, is low. Seismicity is low. And this is the geological map showing the place. So this Mesohellenic Trough is close to Revena. So we have a quite long place. Here on the right side, we have the potential geological areas in this with the hydrocarbon exploration wells. In West Macedonia, we have also Florina Basin. I don't know if everybody knows that Florina, we have all this Xenonero water, for instance. So that is water comes from a place where CO2 is already there. So that's why we have also this acidic water. What that means for us, for CCUS, that it's already there. CO2 is already there. Geologically, this comes from volcanic activity over a million years, but this was trapped, CO2, and then a company went there and get water with CO2. So that means that we have a place where CO2 is already trapped. So we call that as a natural analog. That means that we have a place where we know what we're going to do is there. Produced from, let's say, physical activities in the past. So what we would like to do now is to find places like this, like Florina, to put CO2 underground. So probably nobody knows that this place contains CO2. So it's very well stored without any problem to the environment. So this is we show all the geological information, and we show similar characteristics that the characteristics we try to find in other places in Greece. So it's a reservoir of around 1 kilometer. There is a cap rock containing marls, Neogen marls and clays. There is a depth of formation at around 300 meters, normal faults, so there is no seismic activities very intense in the area, and the important thing that there is no leakage. So going to Central Macedonia, which is the second place for storage site, CO2 storage site, is the West Thessaloniki place. where we have again a thickness of around 20 to 100 meters, 800 meters. We have a storage capacity of around 35 to 460 megatons of CO2. The main basin storage capacity is 645 million tons of CO2. Storage capacity, depth 900 to 2,400 meters. Porosity 5 to 20%. Permeability, pore volume, injectivity, escape risk very, very low. The important thing is here that we have a distance of this west Thessaloniki area to the port is very close. Which is very important for CCUS technologies, for CCUS activities. Another place is Epanomi. So we have Epanomi field, which contains gas reserves, contains hydrocarbons and non-hydrocarbon gases. And we put also some information about the cap rock. So we have a quite thick cap rock of around 1,600 meters. And the storage capacity is not too much. It's only 2 million tons of CO2 can be stored here. But again, we have information about the hydrocarbon presence, injectivity, temperature, porosity, and other things. Again, the distance of Epanomi from the port facility and industrial plants is very good. Go to Prinos now. With the information we have, everybody knows it's a well-detected and well-known area. So we have here all the storage capacity, the depth, the aquifer, the porosity, which is quite bigger compared to the previous places, 18%, permeability, 50 MD, pore volume, cap rock quality, which is very good, injectivity, leakage risk is very low and seismicity very low. South Kavala. The CO2 storage thickness is unknown, the cap rock is unknown, but we have a storage capacity of around 16 million tons of CO2, space for CO2 5 kilometers, square kilometers, aquifer depth of 1,000 to 3,500 meters, porosity again similar to the previous one, 18%, permeability very similar, leakage and seismicity very similar, that means very low. Yes, Mrs. Arthur is going to give us more information from the Energy and Oil and Gas Company. So I'm going very fast, the same geological information about this. So reviewing the CO2 sites, we have Mesohellenic Trough, West Thessaloniki, Epanomi Field, South Kavala and Prinos Field, giving the storage resources, injectivity, integrity and depth. And the important thing here is that the distance from the major port facilities, so I will give you some numbers, Grevena, Thessaloniki, Epanomi, industrial facilities like Komotini Power Station, TAP, Prinos, Ptolemais, again with Grevena, Thessaloniki, Epanomi. So we have different economics related to oil and gas fields, South Kavala, 800 million euros estimated total investment cost, or saline aquifers of Prinos. Probably Ms. Sardi can give us better numbers than here. And for the non-oil and gas sites, we also have an estimation of CO2 storage related to injection, pre-feed, operating cost, and close down. So what is now, everybody speaks about hydrogen, what is the CO2 and hydrogen combined use? There are some synergies, and we have, as we know, that hydrogen, different sources of energy, of hydrogen production. So we have green hydrogen, blue hydrogen, but we have also storage of hydrogen, and we use more or less the same formation, geological formation as CO2. So we use the porous lithological formations, abandoned rock mines, and salt formations. One thing that is very much related between CO2 and hydrogen is that CO2 can be used as cation gas. So cation gas is the required amount of gas needed to store a gas, like hydrogen in our case. So that means that we use to maintain the desired pressure in the area. But also another thing is the hydrogeneration. We can make CO2 hydrogeneration or methanation, capture CO2 combined with hydrogen to produce methane. So, and methane is an energy carrier. So there are this map of Greece with the natural gas and hydrogen pipeline networks. When we have an expansion of the European gas and hydrogen pipeline, this is going to be a benefit for our country. We have the fact that DESFA has submitted a PCI proposal for the development of a dedicated hydrogen pipeline from Elefsina up to the Greek-Bulgarian borders, in line with the European Hydrogen Backbone Initiative. Chapter 5 is the CCUS implementation in Greece. So what we propose in this work here is hubs. So we have different sectors: refineries, steel industry, chemical industry, cement industry. So CCUS hubs can be in different locations to serve as an open access utility. We found that the ports in Greece are essential for CCUS. We have a typical LNG hub in Revithousa. We know, everybody knows that. So, and there is also another one in Alexandroupolis, with the characteristics as mentioned here in this slide. What we propose is 5 potential onshore hubs in addition to Prinos. So we have Prinos, of course, we have Thessaloniki, Alexandroupoli, Ptolemais, Western Macedonia, Corinthos and Aspropyrgos hub, and Volos hub. So we need we understand that to apply CCUS in Greece is important to examine CCUS value chain and to plan also a roadmap with the necessary steps to make possible this implementation of CCUS. Of course, we need the engagement of key stakeholders and industries. So this is the roadmap as indicated in this figure. So we start from 2023. This is we complete the strategic plan and the creation of clusters. And after next year, let's say starting from next year, 2024, we are thinking that probably a feasibility study is required for Greek CCUS cluster. And then we need probably submission of funding proposal to the European Union. We need to secure the funding for the Greek CCUS cluster in 1 year from now, 2025, and then starting some engineering design for CCUS hub, probably discussing with the most applicable one, which is the Prinos CCUS facility in 2026, placement of order for the building of CO2 carrier vessels for Greek cluster at the end of 2026, construction of hubs probably in Elefsina or IE Theodori 2027, up to 2028, 2029 operation of these hubs in Elefsina and IE Theodori, 2030 starting hubs in Thessaloniki, Alexandroupoli, design of Volos, and going up to 2032 to construct the last Volo CCUS hub. So this is something that we're thinking that it's applicable as a roadmap for CCUS technologies in Greece. I don't know if this, there are also other things to discuss, but this is a first approach. Legal issues is yes. Okay, so I have also put some regular legal issues, but I think also next speaker can give us more information about the licensing process and other things.
If I may add a few things on what Nikos Koukoulas has said is about how we envisage these hubs. These hubs are, in a way, temporary storage. That is, you get from the industry on a short-term basis the CO2. You store this temporarily in steel tanks, and then these are transported with a special CO2 vessel to a permanent storage. In this case, Prinos, or as you've seen, we have identified 4 other areas in Greece which are suitable to be developed in underground storage. But take Prinos, which is the most advanced, as Mrs. Sardi will inform us later this afternoon. Now, a critical point we identified in the value chain of building and operating a CCUS hub is the transportation. Right now, there is a shortage of vessels globally, as you will hear later. Some storage CO2 vessels specialized are under construction right now for the Northern Lights project. These are going to be fully employed in the Northern Lights projects in the North Sea. And Greek ship owners have also recently put orders for much bigger CO2 vessels, understand on a speculative basis. So, CO2 vessels is a weak part in the whole chain because we do not have right now available such vessels to designate. But it is hoped that by the time some such hubs starting being developed in Greece or in other parts of the world, these vessels will be fully operational. So they will take the CO2 to permanent storage such as Prinos, but we could also have other fields developed in different parts of Mediterranean, notably in Egypt, where we're having some depleted gas, oil and gas wells. So this is very early stage, but it's a value chain which is really not well defined yet. So there's a lot of work needs to be done to define the value chain of CCUS when it comes to industry and not just for power generation. Am I clear on this? Yes? Okay.
I would like just to conclude with my presentation that we have already, we know the technology for CCUS. We know the storage sites. We put a time span for CCUS in Greece for 10 years. And then we need to have synergies between production, energy production, storage activities, geothermal energy, blue hydrogen. There are different things to discuss, but also we need to have a political decision to go for CCUS in the future. Okay, thank you very much.
Okay. Are there any questions until this point? Before we move to the next presentation? Okay, we'll come back later on questions. So our next speaker is Yannis Passias. Yannis, you have the floor. As most of you know, Yannis used to head the hydrocarbon research company, and they have, during his tenure, they have carried out extensive work on on storage sites. So he's a man with experience in this field. And Yannis helped us in the study to identify and describe in great detail the various possibilities for storing underground CO2 in Greece.
Okay, so I guess we have to talk in English, but it's okay. Thank you for the invitation. This is something that we always say when we start presenting something, so I did not want to be an exception. My work, although I have an idea, an opinion in general, how is the situation with the CCUS and hydrogen, my work for the study of IENE was especially the geological conditions for storage, and is it financially interesting, can be sustainable from the economic point of view, yes or no. And I'll give you these elements now, but please don't think that I'm a pessimist. I'm the opposite, but we have to be clear and cut on how is the situation in Greece, how much industry we have, and how much CO2 we produce and we emit in the atmosphere. And it is not so much here in Greece today. So, but we will have a look on the positive issues also. So, what is that? Okay. Once upon a time, that was when we were trying to promote the oil and gas exploration and arrive to a production. Because as you can see in the Mediterranean, it is a big hole there, it is Greece, and if we could have the opportunity to develop oil and gas in this area, we should have a lot of CO2. So it is something that doesn't fit very well if everybody is saying that we have to reduce CO2 and we have to protect the environment. I agree, but the activity and the development of the CO2 capture will be, I would say, 80% will be related to the oil and gas industry. Then you have the cement, you have all the heavy industry, but without the exploitation of hydrocarbons, you will never have a big problem on capturing and using and storing the CO2. This is the truth. And if you look at the numbers at the international level, there is no doubt about that. So we lost some time on that, so we cannot say that we can be big part of the CO2 business, because it is a business, it is a commodity, and it is also a hazard. And then there is a lot of discussion on how this balance tilts between the commodity and the hazard according to the conditions of the country, the industry, the importance of the industry in the country, and the sensitivity or sensibility on the environmental issues. So here is the way it works, the storage. And first of all, you have some principles that you have to follow. And the most important is to be sure that you can trap the CO2 when you put it down in the ground. This is why trapping is very important. And you have to be sure that there will not be leakage, because if not, it goes again to the atmosphere, and then you don't have the mineralization, something that we are looking strongly, so that the CO2 connects with the CaO, I would say, making limestone, so mineral. When it becomes mineral at a certain depth, it will never move. You cannot take it back and transport that somewhere else and sell it or whatever. Here you have already a big difference of where the industry is looking for. I can tell you that what is important for the industry, it is not to bring that and mineralize that, but rather make money by capturing, transporting that, and also using that for other products that we may have even for the agriculture. So here you understand that there will be something that it is very, very important. Why and who is interested and who is trying to make money with that, not only to protect the environment. So I said that it is important to have the physical and chemical conditions, and the physical and chemical conditions is something like 70 degrees Celsius, but below 1,000 meters depth. Then you can mineralize that, provided that you have the necessary water, and this kind of water, the saline formations, as we said, that will help this chemical reaction so that it becomes mineral. But the other side, as I was telling you about the industry, is that what they're looking is, and it is the only example we have in Greece, and probably it is something like 70% of what everybody is trying to do now around the globe, is to enhance the recovery of oil by sending CO2, as we used to do with methane also, to increase the pressure down in the reservoir so that you can bring the stuff, I mean the oil or the gas, up on the surface and take it and sell it. And at the same time, there is part of this CO2 that will stay down and will be mineralized. So here you have a double profit. And then it becomes a profit that responds directly to the interests of the industry. And also, it helps to have an identity that is respectful to the environment, which is very good. But this is the game. Now, it takes time. You need a lot of years to prepare the studies, understand, and then you need 10 to 50 years to fill a room, to fill in the ground, underground, the area where you want to store that. So 10 to 50 years, maybe something in between. It is a long time. And this time, a lot of things can happen in the industry, in the economy. So this problem, it is something that the industry takes into account because it is a risk factor that have financial, economical consequences. And there is also another problem is that someone has to confirm, someone has to give a certificate that then you have it there down and you will not have a risk. So you understand that from the point of view of a country, of the structure of the country, of ministries, of important departments, they have to take the responsibility for that. We have to be sure, they have to be sure that when they sign, there will not be risk after 10 or 20 years. This is not science fiction. This is the way it works, and this is why it is important to have a legal framework, that it is not yet ready, and hopefully we have someone here who knows very well all of this and will explain you these difficulties later on, I think. Initially, when Askostis said we started with HRM to working on that, the idea was how can we do so that we can contribute to the economy of West Macedonia, where there was production of lignite, and nobody was sure at this time that lignite will stop very fast, will phase out very fast. But finally, it went quite fast. Other products that could be produced were not in the list. The conclusions of the Academy of Science was not recognized by the political world, and also the low volumes that we have, and the cost which is high of transportation made all of these negative factors, and nothing happened for Western Macedonia. And then we said, let's have a look somewhere else. And so those are the areas. Nikos presented also these maps. This is the scenario. We said, let's try to see in these places what can we do. I'm talking about Greece now. I'll go very fast on that. The estimations of volumes of CO2 that you can store that become mineral at the end is for these locations that looks to be the best is something like more than 10 years of Greek emissions for the Meso-Hellenic Trough, which is close to Grevena. West Thessaloniki is something like 10 years also, and for the Prinos area, 5 years of Greek emissions, which is okay because at the same time, as I said, there you enhance the recovery of oil that is producing now and should increase also. When the risk, the cost and the risk comes in the game, you have to put all of this information on maps and calculate the distances and see where can you connect, how much it will cost the pipe, etc., etc. And you see that the majority, the concentration is in northern Greece rather than south. We have a lot of, it is there where there is a lot of industry for the Greek standards. And so we produced these two maps in order to have an idea where it is interesting, how far it is from pipes, from other facilities, ports, etc. And here you have some elements that were presented already and that we have on the report. And I'll go very fast now at the end on some facts that we have to consider. In 2019, that was the situation from the industry point of view. And now you can take out the 26 from lignite. Probably you can take out 10 or half of that, but there is still production of temperature, I would say, and electricity with lignite. So this is an important fact, and there is the most important fact is that in 2007 we have 115 million tons, and in 2020 we have only 60 million tons of emissions. This is related to the general economical situation of the country and the last years, and then you have this fact which is very important, that the economical scenarios will play in 10 to 40 years in order to recover your investment. And an investor, one of the first things he will look at it is this. The cost of a ton, not million ton, it is without transportation, because we have no idea about the cost of transportation today. It is only theories. It is something like 14 euros. And for Greece, with 60 million tons, well, it makes something like a little bit less than 1 million, while the tax represents something like 7 times more, 6 billion. Think about that this is a tax. If you reduce that, this is a tax that will not go to the country to send that in Brussels and bring that back as subsidies for the renewables. So it is another problem there that will have to be resolved, because there will be positive and negative reactions. And just to give you an overview of what is going on in Europe, we have one project in Greece. It is related to how to enhance oil recovery in Prinos. And please check what we have here. The European Union has 16 projects. Altogether, Europe, with European Union, it is 35. It means that Norway and UK, they have 19 projects, much more than what the other entire part of the European Union has. What are these two countries? Oil and gas producers. No comment. About the cost, the difficulties, we have a good experience of what is the cost of LNG. Is it better to have a pipeline? Is it better to have a vessel? How work the economics of LNG if the distances are small? This is what I present here, but we have no idea about the hydrogen, about the CO2, because we don't have vessels. We have only studies, and it's just at this time that this business starts. So we have no idea about the cost, finally, and it will take maybe a couple of years or 3 or more years to have a better idea about all of this. So my conclusions are that in Greece, and this is why I said I'm not a pessimist, but we have to keep that in mind, in order to have something that works really, we have to combine these three, because if not, we will not have the quantities, the volumes that will support economically something that can be sustainable. And these three reasons are, or criteria is, we need to have the presence of methane and possible exploitation, because when you have methane, you have CO2 that goes out, and if you have methane, you can produce blue hydrogen. It is the only one that works now in the industry, and we need also to have places for the underground storage. Probably we have that. And the creation of transit pole, everybody's talking about hubs now. Well, at least if we could have one, it will be very good. So here we are, and here my presentation finished. Okay.
Thank you, John, for a very clear and interesting presentation. Are there any questions on the presentation by John Vasias? Yes, Vasilis.
Can you mean we need methane? Gas. So that is oil and gas that you mentioned at the beginning of your speech. If you produce methane, you pollute. But without pollution, you will disappear, including myself today. This is the reality. We are in industrial system. So we could produce more CO2 so that we capture, and we have all the conditions to capture CO2. If you don't emit a lot of CO2, who will invest for that? This is my point. Europe, with what you pay in taxes, and me, how the subsidies will arrive in a country if there is no industry? By tax. Who's paying the taxes? You and me. So we will invest on that, but it has to be a success. But in order to be a success, you need to have all this material. You need to have a lot of CO2, because if not, nobody will. It's a product. If you produce not so much quantities of a product, who will invest on that if there is no market? So this is the critical point.
One factor that has not been mentioned is that we've been reading about CO2 coming from other countries.
Oh, can I?
Italy, for example.
Can I answer? Yeah. Now we enter in the real stuff. In the Mediterranean region, the country that has potential to store CO2, it is Egypt. Why? Because there is a lot of production and there is decline in production. When you have decline in production, what you have is available space that is created in the reservoirs. In the same way that it happens in Prinos, which is very small. And parenthesis, this is why Egypt has a big problem now that has a lot of pipelines with available capacity. And this is why they started new projects of exploration, so that in a few years we will have discoveries, production, and they will fill these pipelines. Everybody wants that. The American big companies, they need that. They want that for Egypt. So Egypt today, in a lot of deleted reservoirs, has available porosity, a lot, as Norway. Norway is very fast. What is close in the Southeast Mediterranean, it is Egypt. It is not Italy. So the potential, if you want, the potential, client also for the Southeast Mediterranean, it is Egypt. And probably Israel will look at this, Cyprus in a certain way later on, but even countries from the southern Europe, because the cost will be less to store in Egypt, rather in depleted reservoirs in Egypt, rather than to store in other areas where the cost is higher. No, okay. Sorry.
So thank you very much. Let's move to our next speaker, who is IENE Zanini. She's a lawyer. She's a partner of IENE. She's a partner of IENE. She's a lawyer, and in this instance, she was responsible for looking into the legislative and regulatory aspects of CCUS. One thing we found out when we started the study, obviously, is that there is not any framework, legal or regulatory. So really, IENE, I think she started from scratch. Of course, she had the benefit to look at what other countries are doing, but the ideas she has developed are entirely of her own. So, IENE, you have the floor.
Thank you. Good morning, ladies and gentlemen, and thank you for being with us today. So my today topic is the proposed legal framework for CCUS hub operation in Greece. So let me attempt an introduction. As the previous speaker have analyzed, carbon capture and storage is a critical innovative technology towards the mitigation of the climate crisis effect. So the carbon capture units should be close to large emission sources such as energy plants burning fossil fuels or industrial units with high emissions. What is the scope of the project? The project should be to separate CO2 from other emitted gases, to compress CO2 and then to inject it into geological formations that are suitable for storage of CO2. So, having all this in mind, we should imagine how to structure a legal framework that should follow all this process and to safeguard that this legal framework will cover all aspects and all risks of the activity. And of course, the legal framework that should be structured should be within the perimeter of what the EU legislation has already designed for the activity. So let's have an overlook of what are the legal texts that form the perimeter within we should be and comply. First of all is the Directive 2009/31 on the geological storage of carbon dioxide, which is the text that is addressing to this specific activity. We have the Environmental Liability Directive, which is the 2004/35, setting rules for the environmental liability with regard to the prevention, remedying of environmental damages. Also, we have the ETS directive, which establishes a scheme for greenhouse gas emission allowances trade, so within the European territory. So this is the perimeter within we should design our legal framework. Let me spend some minutes to analyze what is the content of the Directive 2009/31, just to understand what are the main objectives of any national legal framework within the EU territory. First of all is the scope. The scope is to create the foundation for the environmentally safe geological storage of carbon dioxide. So this directive should balance all the benefits from the new activity, the activity of CCUS, with all the environmental impact that this activity could have. The directive jurisdiction. The jurisdiction is, as we can imagine, only the EU territory. So the jurisdiction is only for the EU member states, their European Economic Zone, and of course their continental shelves. So this directive rules only this specific territory. And what are the sections? The sections are, I think, 7 or 8. First of all, we have definition, storage site selection, which is up to the member state's decision. So each member state could decide whether or not adopt this new technology, this new activity, and once the decision is to adopt the new technology, could decide whether where this activity should be developed. The exploration permits. So what will be the process for the exploration permits? What is the process for the storage permits, and also what should be the content for the application for a storage permit, and what will be the content of the storage permit itself. Other rules are for the stages of site operation. So the CO2 should be the main element of the CO2 stream. The operator's liability, what is the operator's liability in case of a leakage or occurrence or other irregularity? What is the stage after, what is the storage site's closure process when it comes to the closure stage, and what is the post-closure process? Whether the operator should transfer all its rights to a specific public authority or not. And with the rights, whether operator should transfer and the public authority undertake the responsibilities by the operation of the operation, not the operation, the post-closure status of the site. Also, what should be the financial security of the storage site operation, and what could be the third-party access. So what are the specific measures that need to be set in order to safeguard that the third-party access will be possible. So how to frame our legal framework as a country? First of all, I would like to explain that Norway is the closest system to the European Union legal framework, as Norway needs to comply as well with the European Union legal framework, because Norway is a party of the European Economic Zone. So the example of Norway gives us valuable information on how to structure our own legal framework. We have a competent ministry, which is the Ministry of Petroleum and Energy. The main act is the Norwegian Petroleum Act, And so we understand that Norway considers that the activity is an activity that is addressed to oil sector, and the rules that have been set concern the prospecting license, the exploration license, the exploitation license, the post-closure transfer of responsibility, the financial mechanism, and additional issues like environmental issues, storage license, and other specific rules. Also, in Norway, the CO2 that is captured is not considered as emitted, so for all these quantities that are captured, they do not have to pay quotas in the ETS system. So we do have in Greece also two main texts that could help and give us valuable direction, as they are considered as successful legal texts. And the first one is the 3468 of 2006, and is about the penetration of renewables to the energy mix, to the Greek energy mix. And the second one is the the law 2289 of 95, as has been amended by the law 4001 of 2011, and is the text that sets rules for the storage sites exploitation procedures. So we can have a taste of the structure that the future legal framework should have. So what will be the architecture of the CCUS Greek regulatory framework? First of all, we need to answer to two preliminary questions. The first one is whether the CCUS should be considered as a petroleum activity or should be considered as a heavy industry activity. This would, the answer on this question would give us the direction of the legal framework and how to structure all the process of permits. The second one, which is maybe the most important, is whether CCUS should be considered as commodity or as a waste. The answer on this question changes dramatically the architecture of the legal framework, because in the first scenario, where CCUS is considered as commodity, everything can be traded. All the stages of the capture, transport, and injection can be traded, and also traded can be traded can be also the quantities of CO2 themselves. So everything can create a new market, and the stakeholders could be a considerable number of investors in the Greek territory and abroad. If it is considered as a waste, so it is a public authority that should undertake the main tasks of the activity, and this is another scenario that is quite different to the first one. So in case that CO2 is considered as waste, then a public authority should call for an interest, then should run a public competition, and finally to proceed to the exploitation licensing. On the other scenario, where the CCUS is considered as commodity, we have the private initiative there to have the key role. State should proceed to issue all the needed licenses, like prospecting, exploration, and exploitation. But it is the private initiative, and there is on the private stakeholders to undertake the whole volume of the activity. So the proposed Greek regulatory framework should have a first section devoted to the scope, a second section devoted to the terms and definitions, and a third one establishing the independent authority on CCUS to undertake the governance of the activity. So let's call it IACCUS, independent authority on CCUS. And the fourth section is about the licensing procedure. So we have three main axes regarding the licensing. The first axe is the CO2 capture permit. The second is the CO2 transport permit. And the third one is the CO2 storage permit. So the legal framework needs to follow the whole process, as I said before. Regarding the CO2 capture permits, we need to establish the eligibility criteria. What are the financial requirements to be met by the applicant? And the permits to be issued should be the environmental permit and environmental impact assessment. Also, rules should be set regarding additional provisions for application process and content, and also what should be the permit content regarding the duration, the withdrawal, the modification, and the transfer or renewal of the permit. So here, at the fourth category, we can understand why we are talking about trading. The transportation permits should be licensed with regards to environmental impact, and then to set rules, including there all the possible modes of transportation, which could be a pipeline network, trucks, or rail. And of course, in order to evaluate what should be the more suitable mode of transportation, it's a multi-criteria evaluation, including there the costs and the environmental impact of each mode. And of course, what is the distance, what is the quantity to be transported, and other parameters. So regarding the storage permits, we need a prospecting license, an exploring license, and finally an exploitation license. So this step has three stages that should be followed. Regarding the prospecting license, again, we need eligibility criteria. The permits to be issued should be environmental permit and environmental impact assessment. Also, we need additional provisions for the content of application and also the content of the permit. And again, we have permit duration, withdrawal, the conditions under which the public authority could withdraw the license, the modification of the license, and also the transfer or the renewal of license. The exploration license also should have the same structure, and the exploitation license also should have the same structure as the previous. Finally, a fifth section should be adopted regarding the potential user, regarding the third-party access, and this is a crucial part of the legal framework. Otherwise, we cannot talk about initiatives and about private sector. A sixth section should be the closure and post-closure stage. So in this section, the operator which is in charge for the site's closure and the post-closure state should undertake the responsibilities for this specific stage of the closure. And afterwards, these responsibilities can be transferred to the competent authorities under particular conditions. At the seventh section, we do need the financial mechanisms, so we need to describe what will be the incentives and other financial schemes, subsidies, etc., in order to support the activity and to give the tools that are required in order to have a considerable development of the activity. The eighth section analyzes the monitoring. So we need to monitor all the parameters that affect the capture, all the parameters that affect the CO2 transport, and all the parameters that affect the CO2 storage. And of course, reporting is the next section that is connected with the monitoring. So we need to establish specific registers, so to collect all information of the sector and of the activity, and to have access to this in order to evaluate what is the impact of the sector in the energy and environmental market. And also, we need to have a structured internal reporting and a structured external reporting. Internal meaning reporting towards the national competent authorities, and external meaning the EU competent authorities. Finally, the 10th section should be the liability. So rules should be set for preventive measures, remedial measures, insurance framework, meaning to safeguard adequate insurance coverage to cover all potential risks of the activity. And another section should be the dispute resolution. What are the disputes that may arise? Dispute resolution potential types of disputes should be dispute between partners of bilateral agreements as to the quantity of avoided CO2 emissions. This is an example. Also, a dispute may arise by mass lawsuits, meaning the local reaction potentially to the activity that is developed in a specific area, and also environmental impacts. In case ADR should be prioritized, but if ADR alternative dispute resolution system is not working, so the Greek judicial system should have the jurisprudence to undertake all these disputes. Also, we need a section for public participation, because we need adequate public consultation prior to adoption of any law text, or on the development of the existing one for CCUS-related activities. Close cooperation of CCUS stakeholders with all local authorities and local community, and of course public availability of important information to ease any concerns to the locals may have. That's why I talked about registers where all information will be published public and open to everyone that would like to have access. Finally is the enforcement. There is no law without enforcement, so we need to establish a compliance and enforcement mechanism in order to ensure that CCUS projects comply with all applicable regulations, either from the EU legal framework or the national legal framework, and also rules that will be able to impose fines and other penalties, or the possible suspension or revocation or withdrawal of licenses and permits in case that non-compliance takes place. So this is the legal framework that we have designed for the activity, having as task to cover all stages of the activity and to undertake all the complexity of the sector. Thank you for your attention.
Thank you very much, Vienia. So you see, it's far from straight. I mean, it's a rather complicated issue, this whole legal and regulatory. When I asked Vienia to look into this, I thought, well, you know, it is something not that complicated. It's more or less straightforward. Okay, we don't have a framework, but she will. Now, what is she unfolded here is really fairly complex. I mean, very logical, but at the end, it looks very complex series of steps one has to take to develop such framework, which unfortunately is necessary, right? Okay, so thank you very much, Vienia, for all this wonderful work. So we have 5 minutes. If you want any follow-up questions on the presentations, please, Mr. Bikos.
Yes. Just one question for the legal firm. Have you opted for waste or commodity after all? Have you opted for waste or commodity? Which is it?
For commodity.
Commodity.
Yeah, thank you for raising that. That was a key issue right from the start, right?
I think that the major legal frameworks on the US, Canada, and Australia, and Norway have adopted this direction of commodity. But still, as elaborating the legal framework, we should analyze also the other scenario, which is waste.
It's a question from John Grigoriou. Yanis Grigoriou.
High level. Yes, a question concerning the EU regulation. Can we, as Greece, transport and store CO2 emissions that are produced in the country somewhere else, like Albania, where the geological environment might be positive, or even Egypt, as John Basias told?
Yes, it is. Feasible, but we need a bilateral agreement.
Between the countries?
Yes.
Sorry. Tell us your name.
Yes, Stavros Niotis from Prime Marine Shipping Company. Actually, on the same question, actually, there's a big question mark about the liability, because as we said, during the operation of the site, the storage site, this is on the operator. But of course, we are storing CO2 for hundreds of years, and etc. So after the completion of the operations, this liability goes to the country. So if we are talking about transporting CO2 from a EU country to a non-EU country, first of all, there is a liability issue with the countries, and the second one, and I think it's also very important because we see it also between UK and EU, the ETS system, there's no ETS system, so there's no commodity kind of issue, and who is going to be liable for the credits.
So, talking about the previous example from Greece to Albania, there the problem that we should take into consideration is that Albania maybe does not have any legal framework. So this is a legal risk. It's not only an environmental or other risk or financial; it's a legal risk. So this should be considered. Talking about the UK and the European Union and the ETS system, my consideration is that whether, if we consider as a commodity the CCUS activity, this will be a competitive market to the ETS system, because we can trade everything, and we can trade also the CO2 as a commodity. So as a product. So this could create a new market on how and when and where to store my CO2 in order to get profit from the storage. And I think that we should consider the two systems together in order to understand how the CCUS could be actually the new sector that will be competitive to the ETS system.
Thank
Okay. If there are, Dimitris, Mr. Papakonstantinou.
Thank you. Some in the audience may feel exhausted watching the exhaustive list of permits unfolding in front of us in this presentation, and I think this list would expand, because I agree with your final comment, Ms. Giannini, that in the future we have to look to the CO2 as waste as well, because if, according to the scenarios of IEA or EU for the net zero 2050 future, then surely most of the quantities of CO2 will be waste. And one question maybe to Kostis, since he also is a member of this study. We understand that congratulations for this comprehensive study, first of all. As you said in the conclusions, the presentation of 5 hubs is an early stage of the evaluation. However, I think it would help us if you could give us an indication, a first indication of costs, of economic evaluation. And by the way, because cost is a very, perhaps the most important factor that has been overlooked, I think, because of the dominance of the environmental factor. And we should inform the audience that next Friday, the Energy Committee of the Academy of Athens organizes the annual event at the Academy offices in the Biological Institute, where Kostis is also one of the key speakers. So if everybody is interested in the Academy of Athens site, you can find all the details and enlist. Thank you.
Dimitris, thank you for the question. We have not touched on the cost issue. This is not that we're not aware of the cost, but we have not touched on the cost issue because it would have meant that we would have to quantify in a sort of way. We would have to make certain assumptions which we were not ready to make. For example, CO2 availability from each hub. We don't know this information. It's very vague. Location in the specific area of each, for example, port, we don't know. So we cannot calculate local pipelines. Storage. We know what these tanks can store, but we don't know how many tanks we're going to have. So there were many variables that we do not have any information. So this is the next step, and we said this very clearly in the study, that we need to carry out a proper cost-benefit analysis. But if you like us to give us an order of magnitude, we're talking about something like in the region of about 15 to 30 million for all the essential mechanical engineering and civil engineering work that will need to be undertaken for each hub. So the variability being on the size of the tanks, which we don't know yet. I mean, the cost could go even to 40 million, but you know, this is if you have a fully operational hub. So eventually these costs will be recapped, I mean, will be reclaimed, because of the size of CO2 volumes being transported and sold. I mean, some of them could actually be sold. We don't know that yet. Who is going to pay whom? This is not clear yet. It's like when you do electrical cable to link two sites, cross-border. Who is selling to whom? Sometimes one point is selling to the other, sometimes you have the reverse. So the industries will produce, send CO2 to be stored. Who is going to pay? The market is not clear yet, and I agree with IENE that we're going to see a new market being developed as a result of this. So the next step of this study is actually to quantify the cost, try to describe the market in which these hubs will operate, and will perform the essential function of taking CO2, carrying it, and burying it, and reusing it. So we're at the very start, I think. We took the initiative to do the study because we thought that somebody should do it, exactly to raise all these questions, to explore the value chain, and get as many companies and actors interested in this area. So, without further ado, I'd like to thank you all for attending this first session. 15 minutes break, and we're back here about 12:05 for the next session. Thank you.